Hi friends! So this is a tutorial video for going over how to split up forces into components. And I'm not really going to talk about the FBDs, but I will talk about how to split up those forces that aren't just in the vertical or in the horizontal direction. And kind of talk through those strategies or some tips for you in trying to do this worksheet when you're writing your FNet equations. So this first FBD, I'm not going to do number 1 since there is that tutorial video on number 1. And I look at this FBD and all my forces are either up and down or horizontal. And the one that I need to break up is F pull. So one helpful method, and some students really like doing it this way because it feels more like your velocity vectors, is you do the vector breakdown to the side. And by looking at this vector, if I thought about that as a velocity vector, I'd be like, oh, it's moving up and to the right. Well, instead of thinking it's moving, you can look at that and say, oh, I'm pulling up and to the right. So that's where your components are going to go too, are to the right and up. And because our axes in this case are just vertical is the positive y and horizontal is the positive x, I don't need to tilt my axes or anything. They just need to be side to side or up and down. And so this will be my F pull y and my F pull x. Now I'm also given the angle, and that's going to be 30 degrees above the horizontal. So I actually like to go to the horizontal and draw that angle in until it is reaching that F pull. So this will be that 30 degrees because it's above the horizontal. So you can do it that way and then come to your diagram and add it in. I've seen lots of students be successful with it that way, calling it F pull X and F pull Y. And then you can look at your FBD and determine what forces might be equal or sum together to give you another force. And then I'd also probably label this. Okay, now let's do number 3. So we've got our force of tension in the horizontal direction, we've got our force of gravity in the vertical direction, and then we have FT2, which is at an angle, so it's both up and to the left. And so we are going to make our components both up and to the left. So up and to the left. And again, if that's like really confusing, you don't necessarily have to do it on your FBD. You can also do it off to the side. One thing to make sure is I think a lot of times we look at our FBD and usually students draw one of the components incorrectly. So a lot of times, in this example, like that one's pretty easy to see if I'm drawing my components like this, right? I can tell that this is going to be the y direction. It's just vertical. It's straight up. And if I'm drawing my vector triangle this way, it's very easy for me to tell the horizontal component because it's just parallel to FT1. It's like an extension almost. So one way, if you find that you can always find the horizontal if you draw it this way, you can always find the vertical if you draw it the other way, but then you have a hard time filling in that other component, is that you can actually draw in your two components like this. And then just move one of them. Especially with this e-learning situation, we can move our components pretty easily. There we go. I've got my vector triangle. I just moved my one component. I stopped drawing my components when they reached kind of those outer edges of my vector. So that's how I knew to draw my component that long in the y direction, is because I looked, well, where does it reach? And in the vertical direction, that component reaches this tall. In the horizontal direction, that component reaches this far. And then that's how I knew where I should stop my component vectors. Another tip, if you are struggling with determining, how to draw maybe in that second component, so maybe you're good with like the horizontal, for example, but then drawing in that vertical is really difficult. You need to have a 90-degree angle in between your horizontal and your vertical, because FT2 should always be the largest component of your triangle, because that is the force of tension. The horizontal and the vertical component combine to give you the force of tension, and so the force of tension should be the largest out of the FTX, FTY, and FT. So your horizontal and your vertical components should be on either side of that 90-degree angle, so that the force of tension is your hypotenuse of that triangle. So again, these are just different strategies to kind of help you check your work when you're drawing these components in, because a lot of times I think you just feel it can feel very like, I don't know if this is right or not. So these sorts of checks can help you with drawing in your components. Okay, now this one is probably the most difficult in drawing your components in, because we have different axes. So that's what I do first, is I'm going to draw in my dotted line for my y-axis and my x-axis. Because again, this is going to help me draw in my components. When I actually know where my axes are, that's going to help me draw in my components, because I need my component vectors to be parallel to my axes. So right away, I think that drawing in FGY is one of the easier components to draw in, because you just extend down from the normal force. Then drawing in the horizontal component is where I see the most struggles. And one of the tips I can give you is that this should be a 90-degree angle. So that's why that horizontal component goes right there. But most often what I see is that students draw it in like this. So first of all, you don't have the 90-degree angle between FG and FG. You don't have the 90-degree angle between FG and FG, or FGY and FGX. You have it between FG and FGX. So that's right away, didn't draw it correctly, gotta erase. The other check that you can make is that this component is definitely not parallel to the force of friction. And FGX is supposed to be combating that force of friction. Or force of friction is combating FGX, rather. They should be in the same direction. We can't label this FGX because that is definitely not parallel to the x-axis. So again, it might help you with these to draw in your components and then just move the one. Move the one that you're not, when you are unsure about it, because at least then you can make sure that it is parallel to that x-axis or to that y-axis. The other tip that I can give you is when you're drawing in your components should be drawn tip to tail. So the tip is the arrow part, and then the tail is the part without the arrow. So your components of your of the vector, you draw in from tip to tail, so that's where they connect. Or you can also think about it as my actual vector, so like my force vector, will always be the same. So this is like tail, tail, and then this is tip, tip. So that's another tip, or strategy, I should say. That's another strategy to check to see if you drew in your components correctly. So I hope this video was helpful for splitting up vectors. If you're still really confused or don't understand how to split up vectors, we should meet so that we can kind of figure out what you're consistently doing wrong, if there is something, and how we can fix that. The last thing I want to talk about is going over angles, like where angles go. And this is something that is really difficult because it does take some geometry knowledge, but there's some tricks that you can kind of memorize, especially if you're in geometry right now, that might be harder to reason through. So first one, let's talk about this FG and where we put 20 degrees. So when I draw in my FG vector on this diagram, I see a triangle right here. And I know that basically my angle between the new horizontal, so my new x direction, and my FG, my force vector, is going to be 90 minus 20, aka 70. Well, normally I don't draw in my vector like that, but I do normally draw in my components something like this, or rather something like this from that dot. And when I look at this angle is the same as that 20 degrees. Hopefully you can, or 70 degrees. Hopefully you can kind of see that. Right, so this is 70 as well. And that means this is perpendicular to the horizontal, right? Because this is our FGY, and this is our new horizontal. So that means this whole thing should add to 90, which means this vector, or this angle, is going to be that 20 degrees. So as a rule of thumb, the angle between FG and FGY is going to be the ramp angle. Excuse me. Then let's look at the last example too and talk about the angle. This one is very tricky, I think. This one is like a little bit more thought intensive. So I see this triangle when I look at that theta. But you can also see this, and we know that this is going to be 90 minus theta, and this is going to be, so this angle right here, will be 90 minus that 90 minus theta, because this is a right angle, and then we know that this is a right angle, so this plus this should give us 180 degrees. So we can figure out this angle pretty easily, and it actually ends up being theta. The other way you might see that, like maybe if you've taken geometry, or if you're learning this right now in geometry, if I draw in this, maybe you'll be like, oh yeah, that's theta. I see that that's theta. But that's what I'm drawing here, is that this is the force of tension. This is my horizontal direction. This is the ceiling. And I can see right there that that's going to be the same angle in my FBD. So hopefully this helped. If the angle thing is something that we're going to keep practicing, that one's a little bit harder to get. Especially if you don't know your how to draw in your components. So components is first priority to understand. Angle is second priority to understand on how to fit that into your diagram, because you can't fit your angle in without knowing your components. So let me know if you have any questions. I hope this helped.